Hello, young physicists. Let me ask you something. When you look at a mirror, do you ever wonder where is its actual center? No, not the middle of the shiny glass, but the center of the big sphere it once belonged to. That center is called the center of curvature. Imagine the mirror is just a slice of a giant glass ball. The middle of that ball is the center of curvature, represented by the letter C. Now here's the rule. If you draw a line from any point on the mirror to C, that line is always perpendicular to the mirror's surface at that point. Pretty neat, right? The mirror behaves as if C is its boss, controlling all its normals. Next up, the radius of curvature. If C is the boss, then the radius R is the boss's personal bodyguard. It never leaves his side. Formally, the radius of curvature is the distance between the pole P of the mirror and the center of curvature C. It's denoted by R. So if you measure PC in a diagram, you've got the radius of curvature. For example, if PC equals 15 centimeters, then R equals 15 centimeters. Simple as that. And yes, this radius helps us in equations later, so don't lose sight of it. Now let's talk about the pole. The pole, marked as P, is just the geometric center of the mirror's shiny surface. Think of it as the nose of the mirror. It's right in the middle, and all distances we measure are usually from the pole along the axis. So, whether it's focal length, object distance, or image distance, the pole is our 0 point, our reference station. Moving on, what's the aperture? Well, just like your eye has an opening to let light in, a mirror has an opening too. The aperture is the width of the part of the mirror that actually reflects light. In diagrams, it's shown as a bigger aperture means more light comes in and we get sharper and brighter images. It's like comparing a tiny window with a big one. The bigger window gives you more view and more light. Finally, let's introduce the superstar of ray diagrams, the principal axis. It's simply the straight line joining the pole P and the center of curvature C. Extend it on both sides and you've got your reference highway for all light rays. Whenever we draw ray diagrams, every special ray is either parallel to, passing through, or reflected back along this axis. It's like the main road, while all other rays are side lanes connecting back to it. Alright, let's test our understanding with a quick example. Suppose in a spherical mirror, the distance between the pole P and the center of curvature C is 15 centimeters. The question is, what is the radius of curvature? Step 1. Recall the definition. Radius of curvature R equals PC. Step 2. Substitute PC equals 15 centimeters. Step 3. Therefore, R equals 15 centimeters. That's it. Always remember, you measure R along the principal axis, never along the mirror's curve.
So, let's wrap this up. We've learned 5 key terms that are the foundation of spherical mirror physics. Center of curvature C, the center of the original sphere. Radius of curvature R, the distance PC. Pole P, the middle point of the mirror surface. Aperture AB, the actual width that reflects light. Principal axis PC, the straight line joining P and C. These terms may look simple, but trust me, they're the building blocks for mirror equations, ray diagrams, and all the magic of concave and convex mirrors. So next time you hold a spoon and see your funny face, think, where's the pole? Where's the center of curvature? And you'll realize even spoons obey physics. That's all for today. Until next time, keep your curiosity sharp and your reflections clear.